In today's video, we're going to be doing something a little bit different. So we're going to be doing some pyrotechnics. So the first one that we're going to do is going to be potassium pentoxide with a manganese molecule and an oxidizer. Now, when these two combine, they can react, and sometimes they can also be done by friction. So this is very similar to how friction reacts with nitroglycerin. And this is just a little video demonstrating it. So first, I put about 0.5 grams of the potassium permanganate into a dish. After this, I'm going to be adding some other chemicals later on. So when I do this reaction, potassium permanganate is going to be a very strong oxidizer. That's because it has 4 molecules of oxygen. So when I add the hydrogen peroxide, it's going to react and it's going to bubble and it's going to decompose the hydrogen peroxide, which is also an oxidizer. So this is just the actual friction test of the molecules. So it's going to be a little bit of sucrose, which is just sugar, but it's more of pure form of sucrose. And I'm just going to be mixing this with some of the potassium permanganate. Now when I do this, these two molecules are going to create friction, which is going to create heat. Now this heat is going to very slightly melt the sucrose, and it's going to be attacking the oxygen. So carbon and oxygen are going to bond, and this is just simply going to react. As you can see, I hit it with a hammer. It doesn't work very well, but I'm gonna try something else to try to see if this reaction actually works. So immediately when I mix these together with high friction, you can clearly see that a purple has started to accumulate. Now this is going to be solid potassium. It's going to be potassium hydroxide, and it's also going to be permanganic acid, which has a very, very, very strong purple color. Now this is just the actual reaction, but with using fire. And it's going to give off a very nice flame and a lot of smoke, and it's going to normally be used in weapons such as explosive or fire rounds, which normally require this chemical to be inside the actual bullet. So I see I have a torch, and the reaction starts immediately. Now in this next one, I'm going to be using phosphorus, which I extracted from a matchbox. So as you can see here, I have a mixture of phosphorus and potassium perchlorate. Now potassium perchlorate is even a stronger oxidizer than potassium permanganate, and it still has 4 oxygen. After that, I'm going to add a little bit of gunpowder to kind of kickstart the reaction, but this is not necessary because the phosphorus and the actual potassium perchlorate are actually going to react together without anything, but the gunpowder is just going to make it a little bit nicer. I'm just going to be adding a little bit more just to make sure that this reaction actually works, and it gives us a very nice color. So phosphorus is extremely flammable, so you should really be careful with phosphorus. Also, I'm not even sure if it's legal or anything, but yeah, in some states it's not. But anyway, here's the actual reaction. So you have a very nice purple reddish flame. The reddish flame is actually coming from the phosphorus and the potassium perchlorate, and the purple flame is from the potassium nitrate from the gunpowder. I actually have a video of gunpowder about this and the actual process of making gunpowder, so you can go check that out. Now in this next one is going to be a combination of aluminum powder, magnesium powder, potassium nitrate, and a little bit of sugar. So because I didn't grind the aluminum so well, and I was a bit impatient in the actual making of this chemical, it didn't work out very well, but later on, as the aluminum and the magnesium melt and bind together, it will actually work. So this is also another type of pyrotechnic, and it's called a metal fuel pyrotechnic. Now these are not normally going to be used also in weapons, and also in road flares in small amounts, and also in sparklers. So the magnesium itself is a metal, and it reacts with heat, and it makes magnesium oxide, which has a very bright white color, which you can see. Also, a lot of liquid metal splashing around, which is from the aluminum melting. The aluminum is going to react with the potassium nitrate, and the sugar is just going to add more of the carbon, and it's just going to help melt everything together. It would have been ideal to add sulfur instead of the sugar, but I didn't have any sulfur left, so I just have to come up with something else. Even though it wasn't still perfect, it still worked fairly well, and it burned the wood fairly well. So this next one is just going to be it's going to be a road flare. So this road flare is also homemade, so it's going to be using potassium nitrate, sucrose, a little bit of the phosphorus, potassium perchlorate, and strontium nitrate. Now the red flame that you're about to see is going to be caused by the strontium nitrate. By itself, even though it's an oxidizer, it doesn't work very well by itself, but when it's combined with potassium perchlorate, a little bit of phosphorus, potassium nitrate, and the sugar, it gives us a very, very nice red flame. And ideally this is normally used in something like police road flares that you see outside. Obviously it's much more concentrated, and it uses a metal fuel instead of a regular carbon fuel, which normally works better. But even though it wasn't the actual metal that caused the reaction, it still worked pretty well, and it was hot enough to melt. So this is the end of the video. Thanks for watching. If you want to subscribe, you can do that too. I mean, it's free. So anyway, thanks for watching.